Welcome to the Deep Dive. We're the show that tries to cut through all the noise in tech, giving you the shortcuts to what really matters. Today, we're zeroing in on something absolutely crucial for making applications fast: caching. So our mission for this deep dive, we're going to unpack three really popular caching tools: EHCache, Redis, and Memcached. We'll look at what makes each one tick, their sort of unique superpowers, and crucially, how they plug into Spring Boot applications. The goal is to figure out when you'd pick which one to make your software speedier, more efficient. We've gathered insights from some pretty accessible sources, focusing on why these things are useful, how they fit in, without all the crazy jargon.
Exactly. And, understanding caching isn't just for the hardcore developers. It's actually fundamental if you want to grasp how so many modern web apps work, the ones you use every day. This deep dive should give anyone, really, some crucial insights into the mechanics that deliver that speed we all kind of expect online now.
Okay, so let's kick things off right at the start.
Right.
Why? Why do we even need caching? What's the basic problem it's solving?
Yeah, good question. It really just boils down to speed and efficiency. Think about it like this. Your app often needs the same bit of info over and over. Maybe it's a user's profile or a list of best-selling products, something like that. Every time it has to go get that data from the original source, like a database, maybe an external API. Well, it takes time. Sometimes a lot of time. Caching is basically just storing a copy of that frequently used data somewhere much closer, somewhere faster. So next time it's needed, boom, it's almost instant.
Oh, okay, so it's like, I read this analogy, keeping your favorite snacks right there in a kitchen drawer instead of running to the store every single time.
That's a perfect analogy.
Because those trips to the store, they add up. They
Um,
become a bottleneck if you're constantly wanting snacks.
exactly. And just like those trips wear you out, constantly hitting a database or an external service puts a strain on your servers. The benefits of caching are pretty huge, actually. Apps feel way faster, more responsive. You drastically cut down the load on your databases. That saves resources, saves money sometimes. And crucially, it lets your application handle way more users without grinding to a halt. So it improves scalability big time.
Okay, makes sense. So given those benefits, what are these tools then? EHCache, Redis, Memcached? What actually are they? Let's get a handle on the contenders.
Right. Let's start with EHCache. If you're primarily in the Java world, EHCache is, well, it's often the first one people mention. It's designed specifically for Java apps. Think of it like a super fast local notepad for your application where it can jot down answers it needs frequently.
Okay, so Java-centric, lives inside the app itself.
Often, yes. It can run in process right within your Java application's memory. It can also store data on disk, which is important. You see it a lot with Spring and Hibernate projects.
Got it. Then there's Redis. You hear that name constantly.
Redis. Yeah, it's kind of a Swiss Army knife. It's incredibly fast, runs in memory, but it can act as more than just a cache. It can be a database, even a message broker.
So more versatile. How does it differ from EHCache in where it runs?
Right. Key difference. Redis runs as a separate server. Your application connects to it, usually over the network. Think of it like a shared digital bulletin board where frequently needed info is posted for quick access by potentially many different applications, not just Java ones. It's known for handling more complex data types too, like lists or sorted sets. Twitter, for example, uses it heavily.
Interesting. Okay, and the third one, Memcached. You mentioned big websites use it.
Yep, Memcached. Its whole philosophy is speed through simplicity. It's also a separate in-memory server, like Redis, but it's really focused on being a super fast, lightweight cache for simple data, primarily key value pairs, like a quick reference card.
Just basic lookups.
Mostly, yeah.
Yeah.
Very, very fast at that. It's designed to be easy to scale out by just adding more servers. Sites like Facebook, YouTube, they use it to handle massive amounts of traffic for things like session data or profile info. Big downside, though. Data's gone if the server restarts. It's purely in memory.
Okay, so we have these three distinct tools. Now, this is where it gets really interesting, right? They all cache, but what are their unique strengths? Their superpowers.
Exactly. Let's dive into that. Starting again with EHCache. Its biggest advantage, especially for Java apps, is that in-process speed. Because it can run right there inside your application's memory, there's virtually no network latency. It's incredibly fast for data the app needs frequently.
Like reaching across your desk instead of making a phone call.
Precisely. And it's very Java-friendly. Integrating it with frameworks like Spring or Hibernate is often, well, pretty seamless. Developers familiar with Java feel right at home.
And you mentioned persistent storing on disk. That sounds important.
It is. That flexibility to store data either in fast RAM or on slower but persistent disk is key. It means your cache data can survive an application restart. EHCache can even manage tiers, moving less used data to disk automatically.
What about scaling? Can it handle multiple servers?
It can, yeah. EHCache has features for distributed caching, sharing data across a small cluster of application instances. It works, but setting up and managing large distributed EHCache setups can get pretty complex compared to the others. It shines brightest in single apps or smaller clusters.
Okay, clear. Now, Redis, the superstar. What makes it stand out so much?
Right, Redis. Its strength is that combination of blazing speed and just incredible versatility. Because it's in memory, responses are near instantaneous. Think real-time things. Gaming leaderboards, live chat messages, notifications.
Stuff that needs to be immediate.
Exactly. But the real game changer is its support for complex data structures. It's not just simple key value. It natively handles lists, sets, sorted sets, hashes, geospatial data.
Whoa, okay. What does that let you do?
Well, with sorted sets, you can build those real-time leaderboards easily. Lists are great for message queues or activity feeds. Hashes are perfect for storing object-like data. It opens up possibilities way beyond basic caching.
That sounds powerful. Does that make it harder to use, though?
It definitely has a bit more of a learning curve than Memcached, yeah, because there are more commands, more options. But the payoff is huge. It's also built for scalability. Redis has clustering and replication built in, designed from the ground up to spread data across many, many servers. Ideal for large, busy applications or microservices.
Microservices,
Yeah.
right, where you have lots of small services talking to each other.
Yep. Redis can act as that fast, shared data layer for them. And it offers persistence options, too. It can snapshot its memory to disk, so you don't lose data if the server restarts. Plus, it's multi-language Python, Node.js, Ruby, Go. They can all talk to Redis easily.
Okay, that's a compelling package. And finally, Memcached. What's its core advantage? Simplicity?
Exactly. Memcached superpower is its extreme speed achieved through sheer simplicity. It does one thing caching simple key-value pairs and does it incredibly well and incredibly fast.
Because it's lightweight.
Very lightweight, minimal overhead. That means it's easy to use, easy to set up, teams can get going with it quickly, and it's highly scalable in a straightforward way. Need more capacity, just add more Memcached servers to the pool. The client libraries handle distributing the keys. It's designed for horizontal scaling.
So good for high-traffic sites needing simple, fast lookups.
Absolutely. It uses low resources, doesn't demand much CPU or memory for what it does, and it's proven, like we said, massive sites rely on it. Its limitation is the lack of persistence and only handling simple data, but for many use cases, that's perfectly fine.
Okay, so we see their individual strengths. How do they stack up if we put them head-to-head? What are the main decision points?
Right, let's compare them directly. First big difference, where they run. EHCache, typically inside your Java app, in process. Redis and Memcached, they're separate servers you connect to over the network. That impacts setup, management, latency a bit.
Okay. What about data storage? Persistence?
Data storage, EHCache, flexible. Memory or disk. Data can survive restarts if configured for disk. Redis, primarily memory, but can persist to disk. Offers reliability options. Memcached, memory only, purely volatile. Restart means data loss. Speed is the priority.
Got it. And the kinds of data they handle?
Yeah, data types. EHCache, basic key value, can handle complex Java objects, sometimes needs tuning. Redis, the champion here, handles many complex types, natively lists, sets, sorted sets, hashes, etc. Very versatile. Memcached, simple key value pairs only. That's its focus. Keeps it fast and lean.
Makes sense. How about scaling out to handle more load?
Scalability, EHCache. Good for single apps or small Java clusters. Scaling to very large distributed systems can be complex to configure. Redis, built for it. Excellent support for clustering and distributing data across many servers. Designed for large scale. Memcached also scales very well horizontally. You just add more servers to the pool. Simple, effective distribution model.
And finally, just ease of getting started.
Right, ease of use. EHCache, often the easiest for Java developers, especially with Spring Boot's help. Feels very integrated. Redis, more setup involved because it's a separate server. Steeper learning curve due to more features, but very powerful. Memcached, generally very simple to set up and use for basic caching needs. Minimal configuration.
Okay, that comparison is super helpful. Let's bring in Spring Boot. It's huge for building Java apps quickly, makes things like adding caching way easier. How do these three actually plug into a Spring Boot project?
Yeah, Spring Boot's caching abstraction is fantastic here. It simplifies things a lot. And caching is super useful in Spring Boot apps, right? They're often talking to databases, calling external APIs, maybe doing complex calculations.
All things that can slow you down.
Exactly. So caching makes those apps faster, reduces database load, helps them scale, and honestly, it makes development easier because Spring handles a lot of the boilerplate.
So how does EHCache fit in? You said it was easy for Java devs.
With EHCache and Spring Boot, it's almost seamless. You basically add the EHCache dependency to your project file, add one line in your configuration to tell Spring, hey, use EHCache, and then you use a simple annotation like @castable on your methods.
Like on a method that gets user data from the database.
Precisely. You put @cacheable on get user profile, userid, and Spring Boot automatically handles checking the EHCache first. If the profile is there, it returns it instantly. If not, it runs your method, gets the data, puts it in the cache, and then returns it, all transparently. It's really elegant for Java-centric apps.
Nice. What about Redis with Spring Boot? More setup.
A bit more, yeah, because you need that separate Redis server running somewhere. Could be on your laptop, could be in the cloud. You configure Spring Boot with the server's address. But once connected, Spring's caching support works beautifully with Redis too. You still use annotations like @cacheable. Redis shines here for larger apps, or especially microservices. Imagine multiple different services needing access to the same cached data, like user sessions or configuration. Redis provides that fast, shared cache accessible by all of them, even if they aren't all Java.
Ah, so it acts as a central hub.
Exactly. And you can leverage those complex data types if you need more than simple caching, using Spring Data Redis directly. It offers huge flexibility and scale, despite the initial server setup.
Okay. And Memcached with Spring Boot, you mentioned it's less common.
Yeah, it's not supported directly by Spring Boot's core caching abstraction out of the box like EHCache and Redis are. You typically need to pull in a specific third-party library like Spimecached or Memcached, along with some configuration code to bridge the gap.
So a bit more manual work.
A bit more, yes. It's still perfectly doable, though. You'd consider it if, say, your Spring Boot app needs to integrate into a larger existing system that already uses Memcached heavily. Or if you just need really simple, really fast key-value caching and you're okay with the lack of persistence and the extra setup step in Spring. But generally, for new Spring Boot projects, people often lean towards EHCache or Redis because the integration is smoother. Just remember that crucial point: data vanishes on restart.
Wow. Okay. We've definitely covered a lot of ground. It's crystal clear now that there's no single best cache. EHCache, Redis, Memcached, they each bring different strengths to the table.
Absolutely. It really depends on the specific needs of your project. So maybe a quick summary framework for choosing.
Yeah, that'd be great.
Okay. Choose EHCache if you're primarily building a Java Spring Boot application. You want the simplest possible integration, maybe need that disk persistence for reliability within the app itself, and you're likely running on a single server or a small cluster. Choose Redis if you need high speed plus support for complex data types, lists, sets, etc. You're building for large scale with multiple servers or microservices. You need features like messaging, or you have non-Java applications that also need access to the cache. Persistence is also a solid option here. And choose Memcached if your main goal is raw speed for simple key value data. You need something very lightweight and easy to scale horizontally for web traffic. Data loss on restart is acceptable, or you're integrating with an existing Memcached infrastructure.
That's a perfect summary. So think about your project's size, complexity, data needs, persistence requirements, and maybe even your team's comfort level when you make that call. All right, here's something to maybe ponder after this deep dive. As our applications get more and more distributed, spread all over the globe, how might the evolution of these caching tools, or maybe even new ones, continue to fundamentally shape the architecture of the internet itself? Something to think about. Thank you so much for joining us on this deep dive into caching with EHCache, Redis, and Memcached. We hope you feel better equipped to choose the right tool for the job.